Good morning, class, and welcome to the final lesson of 2020. So today we're going to wrap it all up. So you should have all of the notes written down, and you should have all of the examples completed. Okay, remember, it's okay if they're incorrect. You just need to show me that you're attempting, making an honest attempt. All right, so we're going to go back to that bullet point that I skipped when we first derived the quadratic formula. So that page with the really long process of completing the square to get that quadratic formula, we're going to go back to that bullet point there. So it says which is called the discriminant. Discriminant. I think I spelled that discriminant. Yep. And what the discriminant is it's the b squared minus 4ac part of the quadratic formula. So here's our quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. The discriminant is just the part underneath the radical. Dog. Sorry, dog wants out again. I think he just likes to play outside. Traffic was loud, so I shut the door, but he wants back out. Okay, so the discriminant is just the part under the radical. And why we care about this part of the quadratic formula is because it can tell us what type of answers to expect. So it tells us the number and types of roots of a quadratic equation. And remember, another word for roots is zeros. And another word for zeros is the x-intercepts. So basically what this discriminant is going to tell us is we have this parabola that's crossing through the x-axis, and it's going to tell us, is that crossing through at the point like -5 or -5.73125, right? Like, is it an integer? Or is it an irrational number, or it could be imaginary. So that discriminant, the b squared minus 4ac, will tell us that. So after that page where we solved using the quadratic formula, we've got a chart. Yay, I know we love charts. So our first example is going to be the quadratic x squared minus 6x plus 8 equals 0. So here's a quadratic equation where we would need to solve for x, but all we're going to do today is find the value of that discriminant, okay? Just the b squared minus 4ac, and we're going to talk about what that means for our final answer. So the value of this discriminant would be b squared, so I'm still in the first box for this one. So remember, it's -6 squared, and a negative times a negative is a positive, minus 4ac. So b squared minus 4. So right here, I've got, my example, x squared minus 6x plus 8 equals 0. But just to find the value of the discriminant, b squared minus 4ac. -6 squared is 36, minus, well, 4 times 1 is 4, and then 4 times 8 is 32. So what's 36 minus 32? 4. So the value of this discriminant is just 4. What's special about 4? Two things. It's positive, and it's a perfect square. Okay, so that is important to note, that the value of this discriminant, b squared minus 4ac, is greater than 0, so it's positive. And a perfect square. Okay, so 4 is positive, greater than 0, and it's a perfect square. That means that the number and types of roots that we will have, since it's a perfect square, when you take the square root of a perfect square, you no longer have a radical. So there's no more radical in your answer. So your answer is going to be rational, right? If there was a radical left in the answer, it would be irrational, like a number that goes on forever, like pi, irrational. But since it's a perfect square, the radical's gone, so it's a rational number. So the type and number of roots it will have is 2. Okay, they're real because it's positive, and they're rational. So 2 real rational roots. If your number is positive, that's what makes them real. And if it's a perfect square, that's what makes them rational. You're going to have 2 because it's a parabola. So it's crossing through the x-axis twice. The next one, we're going to draw the picture of the graph after we finish the next one. If my x squared minus 6x plus 7. Okay, so the example that we're doing here is x squared minus 6x plus 7. So finding the value of that discriminant, just b squared minus 4ac. Okay, so again, b squared, negative 6 squared minus 4ac. We've got 36 minus 28. So that number, the value of that discriminant is 8. So again, 2 important things. 8 is positive, but this time 8 is not a perfect square. Okay, 4 was a perfect square, 8 is not. So if your discriminant, the b squared minus 4ac, is greater than 0, which is positive, but not a perfect square. Okay, so your b squared minus 4ac is positive. It's 8, it's a positive 8, but it's not a perfect square, okay? 8 is not a perfect square. The only difference in these two, it's still 2 real roots, but instead of rational, since it's not a perfect square, the radical will still be in the answer. So that means that your answer is going to be irrational. So we're going to have 2 real, irrational roots. Okay, so let me scroll back to the last page. If we look at the values of the discriminants, 361, this was example 1 on the last page. The value of our discriminant was 361. It's positive, so 2 real, but it's also a perfect square. Remember, the square root of 361 was 19. So if you look at our answers, they're both real and they're rational. Okay, this is a fraction, real and rational. 2 real rational roots. If we look at example 3, we had the square root of 92. So 92 is the value of this discriminant. It's positive, so we have 2 real, 1, 2, 2 real, but they're irrational, okay? Over here, we simplified the radical. Notice how there's still a radical in the answer, and then over here there are decimals that went on forever. We just rounded them. So they're 2 real but irrational. So there's a difference there for you. What this would look like on a graph, okay, over here to the side, would be if you have a parabola that crosses through your x-axis twice. So maybe it's opening up like that, but it's crossing through twice. And this might be negative 10, negative 4. This might be negative 9.73121, blah, 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 blah. And this might be negative 2.713512, blah, 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 okay? But it's crossing through the x-axis at 2 points. It could also be opening down, okay? All that fancy stuff. But they're either going to be rational or irrational roots, 2 of them. All right, next, our example will be x squared minus 6x plus 9 equals 0. Okay, So now we need to find the value of the discriminant, which would just be the b squared minus 4ac. Well, negative 6 squared is 36, minus 4 times 1 is 4, 4 times 9 is 36. So 36 minus 36 is 0. So when the value of your discriminant, when b squared minus 4ac equals 0, okay, that goes in the next box. Something special happens. You have one real root. It could either be rational or irrational. Most likely it's going to be rational, but we don't want to count out the irrational. What that means is that you're taking the square root of 0. So we had an example like that. I think it was example 2. Yeah, example 2. The value of our discriminant here was 0. And so when we found our answer, we had negative 8 divided by 2, which just gave us negative 4. One answer. And I drew a picture over here to show a parabola that was only crossing through the x-axis at one point. So we have one real root. Like I said, usually it's going to be rational. It might be irrational, but most likely it'll be rational. So you've got one real root. Your parabola is only touching the x-axis at one point. Okay? It could be opening up. Could be opening down, but it's only touching the x-axis at one point. So that's if the value of your discriminant is 0. One real root. That should be the easiest one. And last but not least, let's do x squared minus 6x plus 10 equals 0 for our example. Okay. So if you notice, I've only changed the c value in all of these. B squared, negative 6 squared minus 4ac. So we've got negative 6 squared minus 4 times 1 times 10. We've got our 36 minus 4 times 1 is 4 times 10 is 40. So 36 minus 40, okay, we have a smaller number minus a bigger number, is going to be negative 4. Ooh, negative. So remember, the discriminant is the part under the radical. So if you have a negative value, if b squared minus 4ac is less than 0, negative. Doesn't matter if it's a perfect square or not. It just so happens that this is a negative 4, which is a perfect square. Doesn't matter. It could be negative 5. If it's negative, okay, if that b squared minus 4ac is a negative value, then you're going to have two complex roots, which means that they are imaginary. So imagination. I see you, dog. Get a puppy, they said. It'll be fun, they said. He's currently eating a towel that's in his cage. Instead of going inside the cage, he's pulling it from the outside. He's a smart one. He did learn to shake yesterday, though, so he's getting there. All right, so two complex roots, imaginary. What that means for your parabola. We've covered that it's crossing through twice, crossing through once. This means that your parabola is not crossing the x-axis at all. So it's like floating above it or floating below it. Okay? It's not crossing the x-axis. That is how you have imaginary roots, imaginary numbers. Okay? So that would be if the value of your discriminant is a negative. 0. No real roots, but you have two complex roots, so two imaginary roots. All right. Let's get to some examples. Let's do A together. So 7x squared minus 11x plus 5 equals 0. So we're just finding the value of the discriminant, which is the b squared minus 4ac. So negative 11 squared. Negative times a negative is a positive. 4 times 7 times 5 is 140. Tucker, hey, stop it. So 121 minus 140 is negative 19. So the value of our discriminant is negative 19. You do not need to find the values of x. We're just finding the value of the discriminant to tell us what to expect for our x values. So since it's negative, we'll have two complex roots. And like that would be your answer, okay? I want you to do B and C on your own. Find the value of the discriminant. So here the value of our discriminant was negative 19. And then tell me how many and what type of roots? Two complex roots. So basically finding the value of the discriminant, b squared minus 4ac. And then you're going to have one of these four options as your answers. Either two real rational roots if the number was positive and a perfect square. Either two real irrational roots if your number was positive but not a perfect square. One real root if it was 0, and two complex roots if your discriminant is negative. You will be expected to know how to do this on your take-home quiz, okay? So there's that. Also, just wanted to point out that the example that we did here, example 5, the value of our discriminant was negative, so there's my two complex roots where we had that I, that imaginary part. And that's all, folks. That was chapter 9 for you. Quadratic functions. So I hope you enjoyed it. I hope you learned a little bit. Again, I know it's not the same as being in the classroom. I really miss you guys. I hope you're doing well. And I hope to have the take-home test posted later on today, which is Friday, May 15th. So have a great day, and hopefully I see you soon. Bye.